let me remind you guys, be careful. There's a lot of terminology this chapter, and I've warned you guys earlier, and I'm going to warn you again. If you go into these quizzes and this test with never looking over your notes, you're in real big trouble. And if you wait just for the quizzes to do it, you're not in great shape either. And if you just don't even care about reviewing for the quizzes and just wait for the test, you are not going to remember everything. It's just not going to happen. There's just too much stuff to remember. So you got to be reviewing, you've got to be reviewing, you got to be reviewing. John, can you get that door for us? So you got to be reviewing. All right, I got a couple erroneous angle symbols there. Just disregard them. They shouldn't be there. I was cutting and pasting and didn't even notice them, but they are there. So try to ignore them as best you can. That would be great, and that will help you. All right, so this is the second half of the lesson that we did back on Thursday. And so, again, a lot of terminology and a lot of relationships for you guys to remember. You know, don't forget, we started the first lesson with learning how to write a line, how to name it, how to name a ray, how to name a line segment, how to name a plane, all those kinds of things. I'd expect to see some of that on your quiz tomorrow. You know, we got into complementary and supplementary angles. We got into measuring angles. We got into obtuse and acute angles, straight angles, right angles. There's a lot of stuff you need to review. You need to be looking at your notes and going over them. All right, well, today we got to do lines that intersect. I'm going to leave the first blank there. We'll come back to it in a minute. Lines that intersect. Lines that intersect. I had an extra T on there. Lines that intersect to form right angles. And off to the right here, you can see the illustration of lines that are intersecting to form right angles. So somebody raise your hand. What do we call lines that intersect to form right angles, Alexandra? Perpendicular lines. Perpendicular. P-E-R-P-E-N-D-I-C-U-L-A-R. All right, perpendicular lines. And they are lines that intersect to form right angles. And in reality, you get 4 right angles. So all 4 angles formed are right angles. All 4 angles formed are right angles. So I use the right angle symbol on 2 of the angles. But in reality, it would be on all 4. All 4 of those angles are right angles. They have to be. All right, so don't draw this. I just want you to think for a second. Normally, when you see perpendicular lines, they could cross like that. They could stop. They could stop just like that, and those would still be perpendicular. Again, I'm going to go through. Usually you'll only see one right angle symbol. And here's why. We already learned about vertical angles. Isn't this angle here the vertical of that one? And we learned vertical angles are congruent, meaning they have the same measure. So if this top angle is a right angle, then this angle here must also be a right angle. Has to be. They're vertical angles, they have the same measure. Not only that, but we learned about supplementary angles. These two are supplementary angles. If this one to the right is 90, the other one has to be 180 minus 90, or 90 itself. And that one's got to be 90. And not only that, we again talked about vertical angles, and if this one is 90, then that one has to be 90 or a right angle, and you can see by the fact that one of them is a right angle means all 4 have to be right angles. They have to be, they have to be, they have to be. There's no other possibility. The perpendicular symbol you guys should have seen. Looks like an upside down T. So go ahead and put that between line AB and line CB. By the way, a little refresher. Remember how to name a line. Any 2 points on the line with the line symbol. Do you put more than 2 points? No. Even the line could have 50 points on it. The line could have 100 points on it. The line could have 1,000 points on it. How do you name the line? 2 points and the line symbol over top. Hey, Andrew, I'm going to help you out. I'm going to make a switch. Why don't you come up into this seat right here from now on? Just going to help you to focus. It's easy to lose track back there. Not that you were doing anything wrong. I'm just trying to help you focus. All right, so perpendicular lines. Lines that intersect to form right angles. Okay, number 2. Parallel lines. Parallel lines. Now, most people just think this way with parallel lines. Lines that do not intersect, and that's all they think. That's not necessarily true. Lines that do not intersect. Oh, I wish I had my yardstick, but I don't. Get this crazy thing. Does that look like a line? All right, it's pretty big. Looks like a line. It's like the thing to turn the shade. Oh. Grab a ruler. All right, here's a ruler. Here's my second line. Okay, if you just say lines that do not intersect, what if I had one line following this ruler, right? Goes forever both directions, yes. And this is the other line. Goes forever in both directions. Are they intersecting, yes or no? What? They're intersecting? Are they intersecting? Okay. Are they parallel? Yes. No, they are not parallel. No, they are not. So if you just say lines that don't intersect are parallel lines, that's not technically true. These two lines are not parallel lines. You got to add one little word in there that makes it correct. Lines in the same plane that do not intersect. Lines in the same plane that do not intersect. Those are parallel lines. So again, let me go back to the illustration. These two lines are not in the same plane. This line is in a different plane than this. Okay? And therefore, then, we have a problem. Now, if I put them in the same plane, that would be in the same plane. They're intersecting, not parallel. That would be in the same plane, intersecting, not parallel. That would be the same plane, intersecting, not parallel. And no matter how I do it, if they're in the same plane, in this situation, they are not going to be parallel. Now, if I keep them in the same plane, now they're parallel, right? This one will go on forever. This one will go on forever. Neither one will intersect. Lines in the same plane, get out of here, that don't intersect. All right, so the parallel symbol looks just like two parallel lines. It's two vertical lines right next to each other. Two vertical lines right next to each other. And you can see over here on the right the illustration. No matter how far those lines keep going, they will never intersect. Okay? To the right there, I drew them at an angle. That's fine. If they keep going forever, they're never going to intersect because they are parallel. They are parallel. The distance here stays the same. Okay? Not a big deal. I think you guys know the aspect of parallel lines. Again, though, be careful. They got to be in the same plane. All right, with that now, we need to do something. Here's a term you probably have not seen before. It's called a transversal. Transversal. T-R-A-N-S-V-E-R-S-A-L. Trans and then versal. V-E-R-S-A-L. T-R-A-N-S-V-E-R-S-A-L. What is it? It is a line that intersects two or more lines. A line that intersects two or more lines. And here's what's going to happen. We're going to have all these special relationships. And that's what we're going to do here in the next couple of aspects here. So 3 special relationships are formed when a transversal, just need to get you used to that word, when a transversal intersects two parallel lines. All right, so we've got to learn some relationships. So if you look on the right here, I've got line A and line B, and you can see by the symbol right there, they're parallel. So we're told line A is parallel line B. The red line right here is the transversal. We get a bunch of angles that are formed. Right now I want to look at the angles between the two parallel lines, right? So just to be clear, angle 3 is right here. Do you agree it goes like that? Does that make sense? Angle 3? I'll get out of your way here, Kirsten. Angle 4 goes right here. Does that make sense? Angle 4. Angle 5 is right here, right, going like that. And angle 6 is right here, going like that. You follow where the angles are? Okay, it's important that you understand where each one's located. So here's what we end up having. We end up forming two pairs of what we call alternate interior angles. Two pairs of alternate interior angles. Okay, so let me see if I can get you guys to understand what we're talking about. One of these sets is angle 4, and the other one is angle 5. Leave some room between them because we're going to put a symbol between them. Angle 4 and angle 5 are alternate interior angles. So let me see if I can get you guys to understand why we call them that. So angle 4, again, is right here, yes? And angle 5 is right here. Do you see how one is on one side of the transversal, the red line, and the other one is on the alternate side of the transversal? That's why we call them alternate. The other aspect is, do you see how they're in the interior? They're in the inside of the two parallel lines. Angle 4 is inside between the two parallel lines, and angle 5 is inside between the two parallel lines. And that's why we call them interior. So those two parts, one's on one side of the transversal, the other's on the alternate side, the other side, so alternate. And they're both between the parallel lines, so alternate interior. Well, here's the relationship. Take your blue there. Alternate interior angles for parallel lines are congruent. So I'm going to stick the congruent symbol between the two angles. That's the equal sign with the tilde over top. Alternate interior angles are congruent. If we had time, I could take a protractor and measure angle 4, and then take a protractor and measure angle 5, and they would be the same measure. It would be exactly the same. Congruent angles have the same measure. Now there's a second set of alternate interior angles, and that's angle 3 and angle 6. Because again, notice one's on one side of the transversal, the other's on the other side of the transversal, and notice they're in the interior. So we have a second pair of alternate interior angles. And again, these are both congruent. So 4 and 5 are obtuse angles, right, that are congruent. And 3 and 6 are acute angles, less than 90, that are congruent. Alternate interior angles. Jordan. Because they are. I mean, look at angle 3, Jordan. Is that more than 90 or less than 90? That's why it's acute. Look at angle 4. Is angle 4 more than 90 or less than 90? It is. Angle 4 right here. It's more, right? So it is. They are what they are. All right. Just so happens that is the case. All right. Second scenario. Notice again the two red angles, angle 2 and angle 7. And again, let me show you to them. Let me show them to you with some color here. Angle 2 is right there. Do you agree? And angle 7 is right here. Don't be marking that on your sheet. You'll end up your sheet all marked up, and you won't know what in the world anything is, all right? Do you agree that's angle 2 and angle 7? Yes. And then angle 1 and angle 8, the two green angles. Angle 1 would be there, and angle 8 would be there. Do you agree we again have alternate angles? The two red alternate sides of the transversal, and the two greens alternate sides of the transversal. So once again, we have alternate. Only I'm not going to say interior next. I'm going to say exterior. Now we have alternate exterior angles. And you know what? As long as the lines are parallel, they're also congruent. Alternate exterior angles are congruent. So again, I'm going to take my red, do the measure of angle 2, leave a space. Oops, not measure, I just want angle. Come back, congruent. Angle 2 is congruent to angle 7. I'll keep my congruent in blue. And our two green ones, angle 1 and angle 8, are alternate exterior, right? They're on the outsides of the parallel lines. They're in the exterior of the parallel lines. Alternate because they go on alternate sides of the transversal, and exterior because they're in the exterior. I need to make this bigger so we can see. All right, so here's now another condition. And this time we have 4 pairs. So you got to look at the green ones, the black ones, the red ones, and the blue ones. Now look at the greens, look at the blacks, look at the reds, look at the blues. Do any of these alternate one side of the red line to the other? The answer is no. They're all on the same side. So these are, we don't say alternate on these because they don't alternate. The term for these are corresponding angles. Corresponding angles. Corresponding angles. And again, if the lines are parallel, and we're told they are, if the lines are parallel, the corresponding angles are congruent. Corresponding angles are congruent. So for time's sake, I'm going to list them all first with their colors, and then I'll go ahead and write the blue congruent symbol. So again, we got in green, angle 1 goes with its corresponding angle, angle 5. And let me pause before we write any more. Don't they look congruent? Look at 1 and look at 5. Don't they look like they're the same size and shape? And of course they would, because they're congruent. Now, later on, when you guys get to geometry in 9th or 10th grade, you'll prove all this stuff to be true with numbers and such, and other postulates and theorems. Believe me, you could take a protractor and measure them, and they would come out true. All right, the red ones, we got angle 2 and angle 6. I should have stayed on the same side of the line. The black ones then, on the left, angle 3 and angle 7. And hopefully they look exactly the same size and shape, and they are. And the last set is angle 4 and angle 8. So with corresponding, they're on the same side of the line. And you're looking for the ones that are the same size and shape. So again, let's put our congruent symbol in between all these. And so we have corresponding angles are congruent. So that's a lot of relationships. So again, let me just recap real quickly. Interior and on alternate sides, alternate interior. They're going to be congruent. That pair and then that pair. Alternate the line and go exterior, right? Like 2 and 7 are alternate exterior. 1 and 8 are alternate exterior. And then the other set are corresponding. They're on the same side. 1 and 5 are on the same side, and they are congruent. 3, bottom of the top and bottom of the bottom are corresponding. They are congruent. Top on the right, top and right on the bottom, those are corresponding. They're congruent. And on the right, on the top bottom, and on the right, on the bottom bottom, those are corresponding. All right, let me show you how we use them. Next page. So this is what's going to happen. If you know one angle, you can get all the rest of the angles. Now, again, you should know what an alternate interior angle is, because I'll ask you, okay, give an angle 13. What is its alternate interior angle? So everybody look at the picture. You've got it there in your notes. What's the alternate interior angle to angle 13? So you're going to give me a number. If you know it on 3, give me the number. 1, 2, 3. 12 is the alternate interior angle to 13. Give me the corresponding angle to angle 16. Corresponding. On 3, give me the corresponding angle to angle 16. 1, 2, 3. No. Quiet, please. Corresponding, same side of the transversal. Corresponding 16 on 3. 1, 2, 3. 12. 12. So again, you got some work to do to make sure you keep straight. Let me give you one more question. Give me the alternate exterior angle to angle 16. Alternate exterior to 16 on 3. 1, 2, 3. 9. All right. So be careful with your corresponding. So watch what happens. They tell us that the measure of angle 9 is 60. So right where 9 is, I'm going to write 60. Now using vertical angles, supplementary angles, alternate interior, corresponding, you can get all 8 angles of these parallel lines. Hey, if that one's 60, you know what? 12 is 60. Vertical angles. Do you agree? Aren't 9 and 12 vertical angles? We already learned vertical angles are congruent. If I know 12 is 60, I could say 13 or 16. 16 is the corresponding angle. 13 is the alternate interior. I'll go to 13. But then I'll also go to 16 by corresponding, right? We know all that. How do I get the next? Now I've done all those. How can I get something else? Josh? Okay, so Josh sees supplementary. So which one do you want to go for, Josh? What number? All right, so if 9 is 60, Josh says 10 is 180 minus 60. So it's got to be 120. What else can you get if you know 120? You can get 11 by vertical angles, 120. What else can you get? 14 by alternate interior angles, right? 120. And what's 15? 120 by either vertical or alternate exterior or corresponding, right? Depending on how you want to look at it. That's the way it is with a transversal and parallel lines. You can get all 8 angles always. Now, they don't always line up nice and beautiful like that. What if they're angled? That's okay. And it's not always necessarily drawn to scale. Just go by what it tells you, all right? Where would you put your 38? Don't say it out loud. Where would your 38 go? Where are you going to stick angle ADT? So again, you got to be able to figure out where to put that. Angle ADT. Well, that's got to go right here. Right? The angle formed with A, D as the vertex, and T as the other ray. Now, if you can't do that, you're going to be in trouble. You've got to be able to figure out where angle ADT is. A's on one ray, D is the vertex, and T's on the other ray. Do you understand now we can get all the rest of the angles? Right? I can get the angle up here by vertical, right? I can go way up top here by alternate exterior if I want, right? Isn't that the alternate exterior with the beginning angle? And I can go in here by either vertical or alternate interior or corresponding. A lot of different ways. And again, how are we going to get the angles on the other side the same way? Oh, by the way, here I am doing the whole thing, and I only asked you for one thing. Angle GHK. Right here, right? So we don't even have that yet. And by the way, you don't need to do them all to get it. How would we figure out angle GHK? Well, again, by the same logic of supplementary angles, and they're all over the place. Here, I'll go on the bottom. If our given angle is 38, what's the other one? 180 minus 38. If you do the math, what is that, 142 degrees? If that angle right there is 142, what is its alternate exterior angle? 142, and we would say it's 142 degrees. So again, if I would have looked at the question, I wouldn't have done the other 38-degree angles. I'd have just gone right from the first 38 and figured out a way how to get up to angle GHK. All right, be careful. Review. You got a quiz tomorrow. Anything we've done so far, and then tonight's homework's page 495. That is the same page you just did. Again, I tried to split it up for you so you wouldn't get too much at one time. 23, 24, 29 through 38. Make sure you're writing originals. Sketch the drawings if you need to. 43 through 46 and 54. Quiz tomorrow. What's the quiz on? Anything we've learned so far, which is 12.1, 12.2, 23, 24, 29 through 38, 43 through 46, 54 quiz tomorrow.